So after opening out that mechanical window, here is the mechanical window where we are going to apply out the boundary condition, and we will be applying out the force value of 6 kN at the free end, and we'll be fixing out the one end. Okay, that is the fixed end. Okay, and once we open out this particular mechanical window, we'll be just clicking on the static structural. We'll be right clicking on the static structural part. Okay, here you can just check out in this particular window the beam that we have drawn out. Okay, so you can also view out this particular beam in the original cross section, how it looks like. I'll just click on the cross section icon at the top. Here is the beam. Okay, so I'll be just fitting out this beam in front view. So from view, I'll be just selecting out front. So in front view, it will be just looking out like this, and we are going to just fix out one end, and we'll be applying out a force of 6 kilonewton at the free end. Okay, the total span, it is 4 meter of this beam, and the cross section, it is 0.35 meter is the width, and 0.35 meter is the height. So I'll be just clicking on the static structural, right click. I'll be just right click on the static structural, and I'll be inserting out the fixity, that is fixed support, first of all. Okay, so I'll be clicking on that fixed support, and this fixed support, I'll be just fixing out this particular beam at the point. So I'll be just choosing out the vertex from the top toolbar, so that point will be highlighted out. So once I just drag out my cursor towards that particular point, here the point gets highlighted out. I'll be clicking on that particular point. Okay, and applying out the fixed support at that particular point. Okay, in this detail fixed support window. Okay, so the blue block shows out the fixity at one end. Okay, now again I will be right clicking on the static structural option and inserting out a force value. So from this I'll be selecting out the force, clicking on this force option. Once I just click on the force option, again I'll be choosing out the point, okay, or a particular node where we are going to apply out a force of 6 kilonewton. Okay, so I'll be just clicking on that and applying out the force from the details tab. Okay, once I just apply out that, okay, the second important thing is that how to apply out that force. Now you can just check out, we are just in the front view, that is XY. Okay, the force is acting out downward, and whose magnitude is 6 kilonewton. So I'll be just selecting out the component from these details of the force component option, where I'll be applying the force in minus Y direction. Okay, so you have to enter out the value of this force, which is 6 kilonewton, and in Newton it becomes out 6,000 Newton. So in downward direction, I'll be applying out it as minus 6,000. Okay, and I'll be just entering out. So once I enter out, you can just check out the arrow, red arrow indicates out the force has been applied out. Okay, now our boundary condition and my force has been applied out on this particular beam. Now the last step, it is to calculate out the deformation in this particular beam. Okay, you can also go with the details of this mesh. Once I just click on mesh, you can just check out the mesh, and you can just go with the statistics of this particular mesh. Okay, still we have not solved out this problem. So once I just complete out with the force and this fixed support, I'll be going ahead with the solution. Now in the solution option, I'll be right clicking on the solution option, and I'll be inserting out the deformation tool. That is, we want to check out the total deformation that will be developed out in this beam, cantilever beam. So I'll be choosing out that. Once I just select out the total deformation, it will be just dropped out in this particular tree. Okay, and once I just complete out the total deformation tool window, I'll be again right clicking on the solution option, and I'll be solving out this problem. Okay, so I'm solving out the problem of a cantilever beam whose one end is fixed, whose other end has been subjected to a point load of 6 kilonewton, whose span is 4 meter, and having a cross section of 0.35 meter into 0.35 meter. So I'll be just clicking on solve option from the solution. It takes some time for solving out the problem. can just check out at the extreme left there is a bar, or there is a tabular bar. You can just check out, it is showing out 5% meshing or meshing done. Okay, so it takes some time and it is ready to give out the solution for this problem. Okay, so once I just click on the total deformation option here that I have dropped from the solution by right clicking on the solution, it will show out the deformation in meters. I'll be just clicking on the total deformation option here. Still the process is of solving is in process. Still it is solving out the problem. Once it completes out that, I'll be clicking on the total deformation icon, and which will show out the total deformation or deflection, okay, in this cantilever type of beam. Take some time for completing out the solution. Just for a minute, wait for some time. It purely depends on the configuration of the laptop or the desktop that you are using out. Okay, the problem solving speed is purely dependent on the version, the laptop configuration. Okay, in industries you will be finding out 16 GB RAM. Okay, for solving out the heavy problems. Okay, easily. Now it is solved out till 85%. You can just check out at the bottom 85%. Okay, it is doing out the numerical calculations for solving out the problem. It takes some time. Once it completes out the entire bar or that green line, it will indicate out it is ready for giving out the solution, okay, for this problem. Okay, it is ready now, and I'll be clicking on the total deformation option from the solution. Once I click on total deformation, you'll be having the deformation that will be induced out in this cantilever type of beam. So you can just check out. Okay, so the deformation that has been developed out at the free end. Okay, you can just check out this from this color pattern. At the fixed end, the deformation is 0, and at the free end where we are applied out the point load of 6 kilonewton, where you are getting out the deformation of 0.05148 meter. Okay, you can just check out the unit, it is in meter. Okay, you can also check out this deformation in uh, mm also. Okay, so if you just want to display out this particular deformation in it is also available. That option is also available, and you can just have the animation also, okay, for this deformation. I'll just play out this which shows out the animation. Okay, uh, after application of the force, how that deformation will be developed out in this particular beam. Okay, you can just check out that this is the animation. Okay, and I'll be pausing out that. Okay, and simply once you complete out this, this shows out the total deformation in this cantilever type of beam. It is 0.0051481 mm. Okay, so this is our first experiment, that is the deflection analysis in the cantilever type of beam. Okay, thanks.